Hello, everyone. Welcome to our first week. So let's sort of go through a little bit right now. At first, here's some helpful links, and I'm going to include some of these in as we go through, but they're just here for you right now. We're going to be doing a lot with Professor Dave. So I was giving these right here, and I thought I'd just use them as primary just as a supplemental videos, but man, he he covers it all pretty well and a lot better than I can with just using my mouse and drawing on the screen. So he's going to help us out a little bit to help really make the concepts and the visuals pop. All right, so about me. So my name is Joseph, from a super small town in Texas, originally born in Oklahoma, but any of you guys know anything about Texans, I don't let other Texans know that. Here's a idea about how that goes. King of the Hill. No offense, but he's from Oklahoma. I don't want to hear that all my life. So after high school, I joined the Navy as a cryptologist, where I did things. Um, Shortly or a few years after I got out of the Navy, I started going to school at Texas State University. Did work in thin film solar cells. You can see these right here. You might have seen these on your news feed. They pop up every now and then. They're pretty cool, really high efficiency, pretty cheap to make. They can go anywhere. I could talk about them for a while. They just have a problem with degrading. That's kind of where the science is at on them right now, trying to fix that. But I wrote my thesis on their degradation and trying to map how that flows. And then after that, I started working at NXP, which is a semiconductor manufacturing place, and Samsung Austin Semiconductors. Currently working from home since my wife started working on her clinical psych PhD. Had to move from Austin down to super South Texas. So I get to hang out at home waiting for this little guy to show up. His due date is on the 29th. So by the time you watch this, he'll probably be hanging out with me in my office. My wife shot down every Star Wars name suggestion. So no Han, no not even Luke, but we went with Liam. So I'll take it. I'll take it. I can take it being adjacent to Qui-Gon Jinn. All right. So getting right into the material. All these charts right here for units can be found in the back of the book. The first section of this we're going to be going through is going to be in chapter B of the book. So it's going to be good to familiarize yourself with some of these, but it's okay. You will pick them up as you go along. This is probably going to be the main thing that you'll be flipping back to double check time and time again. I remember almost halfway through my undergrad, I was still checking in the back of the book and counting out the kilo, mega, milli, nano with my hands, just looking up to the right and thinking, is that one 9 or 6? It's okay. So yeah, these are the standard units. Units continued. So this is something that's pretty helpful to check out. So when you see ms -1, this is -1. Let me annotate. This is -1. Oh, not that. Try. Where you at? All right, blue. Go with this. This is -1 applied to the S, brings it into fraction. So, and I'll cover this later, but -1 is the same as saying 1 over it putting in the denominator. And again, this will be covered later, but s to the -1 is the same as 1 over s squared, and so on and so forth. So this just means meters per second. So this is going over velocity. Read about this. All right. So let's give some examples on converting 3 meters to centimeters. All right, so the given 3 meters. All right, so we're going to work on figuring out how things will cancel out. So we know that there's 100 centimeters in 1 meter. So we set it like this right here, 100 centimeters per putting it in the denominator, 1 meter. So then meters cancel out, leaving us with 3 times 100, 300 centimeters. This is going to get very mechanical after a while, and it'll become second nature. So convert 1500, yeah, 1516 grams into kilograms. Same thing. 1 kilogram equals 1000 grams. So it's 1 kilogram per 1000 grams. Grams cancel out. We end up with this. So, and you can go through, practice these. Recommend just sort of practicing all of this stuff. Let's get stacks of printer paper and pen, pencil, and just remember there's plenty of paper in the world. Don't feel like you're killing too many trees. Just write it out. It's the best way to really etch it in your mind, and you get that kinesthetic feel of it. Converting 5,200 milliliters into liters, same thing. 1 liter per 1,000 milliliters. Milliliters cancel out, 5.2. I'm just going to move right on through some of these. All right. When working with non-metric units and converting them, so for instance, yards to meters or yards to centimeters, we want to convert 2 miles feet. There are, after looking it up anyway, we'll know that there's 5,280 feet per mile. It gives us the amount of feet. Feet to inches, same thing. Feet to centimeters. Here, we know that there's 12 inches in 1 foot. And then we know that then we look up and we find that there are 2.54 centimeters in an inch. So here we're able to go from the standard units to the metric. Cross out the inches. There you go. This will be handy if we're going to be dealing more in kilometers and yeah, as opposed to like miles or something. So just bear this in mind. If there are problems that ask in miles, then you're going to have to do the conversion. All right. So this is it for the section of units. I'm just going to roll right on into some algebra refresher. Remembering the primary thing to keep in mind with algebra is PEMDAS. I'm 100% certain that you guys have seen this in the past. I'm just going to have this right here, this good little graphic as a reminder. And remembering the parentheses in PEMDAS is also just grouping. Another way that this is written out is GEMS, which is groups, exponents, and then multiplication, subtraction, division. I don't like GEMS because it, I don't know. Anyway, so here's a good example of the flow of PEMDAS. Again, as a refresher, we work through the parentheses, or the things that are grouped together first. Then we work through the exponents. Then we work through the multiplications and the divisions. Then the addition and subtraction. And then we get into the quadratic equations. And again, all of this will become second nature. Let me go ahead and bring this out for annotation real fast. So remember, when you have A plus B, A plus B, the way this is going to go is, let's change this color. It doesn't matter which one of these you start with, but it matters that you kind of stick with it. So if we're starting with A, you're going to multiply A by everything in the other one. So then we're going to get A squared plus A B. And then we multiply it by B's. We're going to get, so all of this plus BA, which is the same as AB, plus B squared. Putting it all together, get A squared plus 2AB plus B squared. And again, this will all become second nature after no time at all. Get rid of all this. My first time teaching just a laptop. All right. Go. All right. And then with fractions, the main thing to remember here, as always, is you want to keep the common denominator. So best way to do that is to best way to do that is multiply both sides by the other, so B over B. I guess, and I'll go over all this again later, is it's always helpful to remember that B over B equals 1, just like 4 over 4 equals 1, and so on and so forth. This. All right. Then division by fractions. Remember, when you have a fraction in the denominator, so annotate this again. So just a quick little note on this. So here we see n over a over b. So one thing that's helpful is any number by itself is the exact same thing as saying the number over 1. So this is kind of like saying 1 a b. And when you take this fraction on the bottom, imagine it's sort of like rotating or flipping. So let's see if I can actually this. So I take this guy and oh no. Well, I wasn't expecting to do that. You just imagine this just sort of like flipping so that then you get b over the a. So if it's a, it's a over b. Then this is the same thing as saying n over 1 times, imagine these guys sort of flipping one over the other, and you get b over a. And then math it out from there. All right. Okay. We'll move right into exponents for this refresher. This is from the back of the book, and this is really just a pretty much lays out really well how to visualize the exponents. And then over here, you see what I was referring to earlier with the negative exponent, putting the number, making it such that the numbers in the denominator. All right. And also bearing in mind that any number raised to the power of 0 is just 1. When dealing with exponents, there are several rules. So we have the product rule. The m plus or times a to the n, you're going to multiply those, or you're going to add those two numbers by each other. And you can see the example of how this works here. If a to the n is a n times, and then you're multiplying, right? And then you have a to the m times, and you're still just multiplying a to itself just that many more times, thus giving it so that you're just adding those exponents. And you're just adding the amount of times that a is being multiplied to itself. This negative right here, again, comes from this, where if a number has an exponent that's, if a number with an exponent is on the denominator, it's the same as that exponent just being negative. So then it's going to be m. Let me. Okay. And then the power rule. So if you have this grouped, right, and we'll come into this with some other math that we'll be touching on later, where if there's parentheses and then this is grouped to it, then you're going to be multiplying those two numbers. And touched on this a second ago, a to the 0 is 1. And once more, just to make sure it's home, a to the negative n is 1 over a n. Then there's the distributive property of exponents when numbers are being grouped together. So we have x, y squared. This square distributes to each one of those, giving us x squared times y squared. And same thing with division. So the a to the n, the a over b to the n, this n will distribute to each one of those. So we can look at this. Let me annotate here again. So looking at it like this, x over y, the n, this n goes to the x, and goes to the n. So then we would have just this image here shows x over y. And of course, we know there's another way to written, and that is, let me pick a different color here. That is x to the n times y negative n. All right. So after dealing with logs, or after dealing with exponents, we're gonna get in, we're gonna touch on the nth root and rational exponents. So we dealt with exponents affecting numbers in fractions. So we dealt with exponents. How they interact with fraction numbers. Now, if so here we have a to the negative 2, or in this case, or yeah, sorry, we have a to the 1/2, right? Then it would be that root. So we can see right here, m over n in the exponent. It's going to be the nth root, the nth root, the nth root of a to the power of m, like this. So then we see this example right here of 1/2 giving us the classic squared root. And there's going to be more complex examples of that. So for instance, we have x over 2/3. This would be the same as saying the third root of x squared. All right. Next up, we are going to touch on logs. So